Okay, this is the last page of the exam review. So this section is on quadratic expressions and polynomial expressions. And the first thing we want to review is how do you factor a quadratic? And there's three ways to factor a quadratic. The first way that you always want to factor is by looking to see if there's a greatest common factor. What I mean by that is you look at the two terms. So we've got 5x squared and we've got negative 15x. And you try to decide what is the greatest number that is a factor of both 5 and 15. Well, I know that 5 divides by 5 and 15 divides by 5. So 5 is the GCF. But then you look at the variables. And what's the greatest variable part that they both have? Notice they both have at least one x. So our greatest common factor is going to be 5x. And we pull that to the front of the problem. And then we put our parentheses because this is like doing distributive property in reverse. So we want to think 5x times what will give us 5x squared. So that will become x. Then we do the same thing. 5x times what number here will give you negative 15x. And that's minus 3. So remember, you can always check your factoring by then going backwards and distributing and seeing if you get the original answer. Because we are making two expressions that are exactly the same, just written in different form. So let's take a look at this one. We've got three terms, and you look at the three of them and try to find the greatest common factor. Well, I notice they're all even, and even numbers are always divisible by 2, so our greatest common factor is 2. Now, the reason it's not 2x is because 8 does not have an x term in it, so that's not even a factor of this term. So we just factor out a 2, and then we do just like we did before. We figure out what has to go here, so that when I multiply it by 2, I get 2x squared. So that's x squared. 2 times what gives us 6x? That would be 3x. And 2 times what gives you 8? That would be 4. Okay, the next way we're going to factor is by looking at trinomials. And notice that this trinomial, its leading coefficient is 1. So when you multiply 1 times 12 together, you get 12. So we're looking for two numbers that fit this number pattern. We need two numbers that multiply to get 12, but also add to get 8. And when you figure out those two numbers, so in this case, it's 2 and 6. 2 times 6 is 12. 2 plus 6 is 8. Because this leading coefficient is a 1, we know that our binomial terms are both going to start with an x, because x times x gives you 1x squared. So when you get these two numbers, when this term is a 1, you can just plop those two numbers into the factors and you are done. So we just went from here to here. If you were to multiply this all out, you would get this answer. Okay, the next one, notice the leading coefficient is not a 1. So you have to multiply the a value and the c value together. So 3 times negative 2 is negative 6. And we need to find two numbers that multiply to get negative 6, but also add to get negative 5. So that's negative 6 and positive 1. Now, it's not so easy. We can't just take these numbers and plop them up here because this is not a 1. So we have to do this box method. We have to build our polynomial out, our trinomial. We have to write it out as 4 terms. So the first term always goes in this top box. The last term always goes in the bottom right box. And then we put these two numbers in here and here with an x behind them. So I'm going to do negative 6x and 1x. Doesn't matter where you put these two, they can be flipped around. The next thing you do is you pick a row or a column. So I'm going to pick this row going across here, and I look at these two terms and I find the greatest common factor. Well, I notice that 3 is a factor and x. So this is going to be 3x. And now we fill in all the rest of these numbers by doing what I call battleship. So 3x times x gives you 3x squared. 3x times negative 2 gives you negative 6x. And then down here, x times what gives you 1x, so that would just be a 1. And I see if I did this correctly, 1 times negative 2 is negative 2. So our factors are the dimensions of this square. So one factor is x minus 2. The other factor is 3x plus 1. Okay. All right, the third factoring method is if you recognize that you have not 3 terms, not a trinomial, but if you have a binomial, so 2 terms, and if they are a difference, meaning if you are subtracting them, the next step is you look to see, are both of these terms perfect squares? So can they be written as some number squared? Well, we know 49 is a perfect square, and we know x squared is x times x. So this factors into x plus 7, x minus 7. Let's jump to the last one because that's pretty easy as well. X squared minus 100 is x plus 10, x minus 10. Okay, the middle one is a little bit different because in the first two, x squared becomes just x times x. But now you have to think, what numbers have to go here and here so that when you multiply them by themselves, you get 4x squared. Well, that's 2x and 2x. And plus 6 and minus 6. Okay, the next section is adding and subtracting polynomials. So we've got 2 trinomials that are being added. So what you do here is you locate like terms and you add them together. So 7x squared plus 5x squared is 12x squared. When we are adding polynomials, we do not change the variable. It's like having 7 of something plus 5 of something, and that gives you 12 of that same somethings. Then I notice negative 6x, negative 4x. When you add those together, you get minus 10x. And then 9 plus 8 is 17. You know you're done when there's no more like terms to add together. So we're going to do the same problem here, but now I put a subtraction sign in between. So the subtraction sign is outside of this parenthesis, which means this subtraction has to apply to everything inside. So we do this again. 7x squared minus 5x squared. And that's going to give us 2x squared. Then we do negative 6x minus a negative 4x. Well, remember, subtracting a negative makes it positive 4x. So negative 2x plus negative 6x plus 4x is negative 2x. We do the same thing. We have positive 9 minus positive 8. 9 minus 8 is 1. That's the difference between adding and subtracting. Okay, the next thing you'll have to do on the exam is multiply 2 binomials. So the way that I do this is we put one binomial across the top of our rectangular figure. We put the other binomial along the width or along the side, making sure that the minus 6, this minus makes that number negative 6. And now we multiply row times column. So 2x times x is 2x squared. 2x times negative 6 is negative 12x. 5 times x is 5x. And 5 times negative 6 is negative 30. Now to write your final answer, you always want to look to see if there's any like terms in your rectangle to add together. So our final answer is 2x squared, but then negative 12x plus 5x is negative 7x, and then negative 30. Okay. There will be a question that just asks you to identify these things. So identify terms. So to start out with, terms of a polynomial are all the things that are separated by addition or subtraction. So in this case, we have 5 terms. So one term is 12x to the 5th. Another term is negative 4x to the 4th. Another x is 3x squared, and so on. Okay, coefficients are variables that are in front of, are numbers that are in front of a variable term. So our coefficients here would be 12 is a coefficient, negative 4, positive 3, and 9. Negative 7 is not a coefficient. Negative 7 is a constant, meaning negative 7 is going to be constant in the problem. It's never going to change depending on what x is because it's standing alone. Negative 7 is a constant in the problem. Okay, the last thing is defining a negative square root as the number I. So this is something you can write on your note card. The definition that square root of negative 1 is equal to I. And this is how we would break this down. If we had the square root of negative 4, we're going to break negative 4 down into 2 factors. Notice that negative 4 is the same as saying 4 times negative 1. So in other words, I'm pulling this square root of negative 1 out of this problem. Because now we know that the square root of 4 is plus or minus 2. And we know by definition the square root of negative 1 is I. So our answer would be plus or minus 2I. Okay, so I've got 2 for you to try. If you'd like to pause the video and try them so that you can kind of think about this, but see if you can go through the same process and then restart to see the solution. So what I got is the square root of negative 9. I separated it into square root of 9 times square root of negative 1 because I know that the square root of 9 is plus or minus 3. And by definition, the square root of negative 1 is I. And square root of negative 16 looks the same way. All right, make sure that your note card has some valuable stuff to help you, and good luck.